Recompiling FFmpeg got me somewhere. Whew. I was in the middle of compiling OBS realizing, wait, I don't think I need to do that. I should have the old version still. And it started up, so I waited a little longer than I actually needed to. Thanks for sitting tight. Sorry, I'm starting late. This video is smooth again. This camera here doesn't work. Yeah, everything's going well. Oh dear. I don't think we actually need this other camera. You know, I'm wishing I had tried to start OBS a little sooner. That's what I'm wishing. Well, looks like this camera is going slow. If you wanted to see my leg. Hi, Michael. Hi, Unexpected Maker. Hello, David, Randall, Beata. Hopefully you all are still here. And hopefully the background noise isn't too bad. All this compiling has kind of bolstered the temperature of my room, so I'm just going to leave it on. I think I can turn it down though, actually. It should be a little bit better. All right, is it going? I see we have some more folks on YouTube, but I haven't gotten hellos. But it looks like it's okay. I'm just moving my windows around a little bit. Sorry, I don't have my act together. Can you all hear me? "26 minutes late is too long." Oops. Hi, add me. David says, glad you were able to get it going. Audio good, sounds good. Okay, thanks. Oh, I was a little worried. I did have to change my audio settings too before I started too. Sounded good, okay, great. Michael says, so I'm kind of a new subscriber, so this channel has multiple creators on it. BGS says loud and clear. Awesome, thank you. Okay, so let's do intro and we'll answer Michael's question at the same time. So, hello everyone. Thank you for waiting. I'm supposed to start at 2 and I tried to start OBS and nothing happens. So I had to fix that. My name is Scott. I work for Adafruit, which is the channel. So the channel is for Adafruit. They're an open source hardware company based out of New York City. They do open source software as well. I do the software side mostly. And I work remotely for Adafruit. And I'm the lead developer on CircuitPython, which is a version of Python geared towards beginners on microcontrollers. Microcontrollers are these little inexpensive self-contained computers, so RAM, CPU, and peripherals and stuff, all on a single chip. Makes them really inexpensive to get into, and you can use them in all different places to do all sorts of interfacing with the real world. It's kind of in the realm of physical computing that people do it too. So I'm just one of the folks that works for Adafruit, and so the folks that end up on this channel are different, do different things. So this is Deep Dive. Deep Dive is when I tend to stream. I tend to stream 2 to 4, 2 to 4 Pacific time, so about 2 hours. No label on this. This is the IMX 1011. This is the trace board that I made, and yeah, I haven't put a label on it. And during Deep Dive, I love to answer questions. So if you have questions about CircuitPython, microcontrollers, that sort of thing, please let me know. Adafruit questions are great too. And yeah, so I I tend to cover very technical topics. I am working kind of in the core of CircuitPython, which is actually mostly, it's all C code. So I'm usually in the C code land that underpins the Python side of CircuitPython. So yeah, I tend to just talk about what I've been working on and answer questions regarding that or other stuff and see where the winds take us. So folks have any questions as we get going here? Otherwise, I'll basically pick up where I left off in terms of what I was working on. So it's been 2 weeks since I've done deep dive. Last week, neither Foamy Guy or I did it. The plan is that next week I'm going to be at my parents' house. So I won't be streaming next week, but Foamy Guy is available. So Foamy Guy will be streaming next week in this spot. And for those of you who haven't watched, Foamy Guy tends to do higher level library Python stuff, which is probably the most valuable part of CircuitPython is the libraries, because those are things that support all the different sensors and things. So check Deep Dive out next week for Foamy Guy. And I'll probably be back the week after that. Yeah, this is like cat cam that's like real slow. I don't know why it's I don't know why it's working. You had Michael's question. I think I answered it, yeah. So this channel has multiple creators on it. That is the case, yeah. Adafruit pays multiple people to make content on this channel. Yeah, so I won't be streaming next week. And then I can just talk about kind of what I've been up to the last couple weeks. Where we left off on Deep Dive is I was working on, I think I had finished the IDF 5.1 update. So the ESP IDF is the vendor provided code to interface with the espressif Wi-Fi chips. And we're updating the version of that in CircuitPython so that we could support new chips. And I know Unexpected Maker is going to be interested in this. So that stuff's merged in. Adafruit, or the CircuitPython main branch, is now IDF 5.1. And then the next thing that I did after that was I wanted to re-enable the RGB Matrix. This is something that MicroDev had pointed out. MicroDev did the bulk of the work for the IDF 5.0 update. And he had pointed out that in order to get it going quickly, he had disabled the RGB Matrix support. And you can kind of see in this cat cam that here, this is an RGB Matrix on my desk here from when I was testing that. In fact, I think I was actually trying to get it working on the stream. I don't remember. But I found this issue. Unexpected Maker, you'll be interested in IDF 5.1 status, is what I was thinking. So I found this issue, an RGB Matrix, and people had filed a bug about this as well, where after a little while of using it and like iterating on your code, it hard faults. It crashes into safe mode. And I did let's switch to the desktop. Yeah, so it crashes into safe mode, and I figured out what the issue was. No RGB, literally unplayable. Yeah, so it's not enabled yet. There's a pull request for the RGB Matrix stuff. I pretty much moved on, although maybe it looks like Dan actually. Looks like Dan got to it. I was going to say it hasn't been merged in yet. The invalid pin issue in CircuitPython 9 alpha. I think I saw that issue go by, but I haven't looked at it yet. Yeah, Dan just merged it 20 minutes ago, so great. So RGB Matrix is enabled in main as of 20 minutes ago, which I didn't even know. I was too busy trying to get the stream going to see that. So thanks to Dan for that review. And I also had to update the ESP protocols stuff. So Dan merged that as well. So there was 2 pieces to this puzzle. Let's just take a gander at these 2 PRs, because I did 1 PR, and actually we should probably do an 8.2x merge into main as well, because there was the crash itself, the safe mode crash, is something that was present in CircuitPython 8 as well. So I fixed it there, but then I had additional fixes that went with the 9.0 updates. One simple thing I fixed in 8 is that there's a list of the address pins in 8, but it wasn't updated for a revision, so I fixed that. Protecting against a null pointer here. Get this as big as I can. And hopefully my lighting's a little better. I actually got a second key light, so I've got 2 key lights now. So I should be a little less shadowy, although you can see that I still have this window giving me a lot of light as well. Yeah, Unexpected Maker, go ahead and post a link to the issue and maybe we can take a look at it right now. That's totally something I'm game to look at. So this bug here is that it was using this allocator impulse stuff. What you can see here in the new world is there's allocate memory and free memory. And those are two, I'm trying to, my brain's thinking, is that right? Free impulse. Yeah, I think that's right. Yeah, I think that's right. Maybe I should test it again, but so there's this problem, or this trickiness with RGB Matrix, because we share the ProtoMatter library with Arduino, and it requires it does a couple allocations itself, which is done through this pound define for malloc and free. And so there's this tricky problem where so this free impl and this allocator impl get passed down into ProtoMatter for doing allocations. But the original version, when it freed, it would allocate memory to the supervisor. Stream paused. Let me look. It looks okay from... yeah, what's it say? Back, okay. Oh, the problem was in CircuitPython-dev. What is it telling me here? Restream is giving me a need help button. Oh, it's just marking it as fair. Okay. Yeah, let me know. It looks okay from Restream side, but I might be trying to upload too much. I don't know. So originally, the allocator implementation would say allocate memory, and then return it if it managed to do it correctly. And then to free, it had to do this call from allocation from pointer. So in CircuitPython 8, and main right now, there's this mechanism for doing allocations where the memory gets allocated into the MicroPython heap, and then after MicroPython VM stops, it moves all that memory to the start of where the heap was, so that it can outlast, so it lives longer. But moving memory is really complicated, and like ProtoMatter doesn't expect that to happen. And in fact, this code wasn't expecting it to happen either, because this allocation from pointer doesn't work if the pointer's been moved. So the problem is that it was leaking. This code is leaking these allocations, and the supervisor memory manager thing had a fixed number of allocations it could do, and then after that, it just wouldn't be able to allocate anymore and cause problems. So the main cause of the crash is that we're leaking allocations, supervisor allocations, and then we're running out and crashing. Now there's a separate problem where, so that's caused by, it's doing an allocation. This ProtoMatter RGB Matrix code only holds onto the pointer when it really needs to hold on to the outer object, which is the allocation itself that the underlying supervisor memory allocator gives you, because that outer thing doesn't move, but the pointer stored in it does change. And so the problem here with this way of like, I only store the pointer, and then later when I need to free it, I find the allocation from the pointer. This doesn't crash or give you a warning if you don't actually find anything. So it acts okay, like it did successfully free, but in reality, it didn't free anything. And therefore, it's leaking supervisor allocations. So that was the main thing that I was fixing here. So now you can see that I add this basically like cache of allocations. So I keep track of like, okay, I allocated something with this pointer, and here's the allocation for it. And then when free gets called, I look up in that cache and then free it properly. That works to prevent leaking allocations, but it doesn't actually fix a like the problem that memory is moving. So like if ProtoMatter tries to use a buffer, kind of like, and the way this code tries to get around it is it like tears ProtoMatter down and starts it back up. Yeah, so there's a period of time that still exists after this change where like ProtoMatter could use memory it really shouldn't because it's been moved. Todd has a question in YouTube that says, I need a short little 2-wire with male/female connectors to embed in a 3D printed chain link. Anybody able to assist in the engineering? I would just do like a JST plug. But I have not, I don't know 3D printing that well, so I would take a look at like 3D printing on 3D Hangouts on Wednesday morning is a good place to ask about that. But hopefully other people here will chime in if they have. Offering to pay too. I don't have any experience with that though. Yeah, the Adafruit Discord. So there's 2 chats above me here. The middle one is the Discord. So you can you can go to adafru.it/discord to join it. So you could ask there as well. There's a 3D printing channel. Unexpected Maker says, I have to say, whoever thought of the name ProtoMatter should get a raise. So if you go to the ProtoMatter repo, they cite where they got it from. It says, I used ProtoMatter in the Genesis Matrix, David Marcus on Star Trek 3. So it's a Star Trek reference, which I did not know until I actually read the README here. But yeah, it's a Star Trek reference. Okay, so that's the changes that I did in 8. And the goal is to just like prevent it from crashing or reduce the likelihood that it crashes. And then I had additional fixes in the IDF5 main update stuff. So I had to update ProtoMatter because it didn't compile with 5.1, so I had to do some changes there. There's some new code that Jeff had added for using Q-strings as compression tokens, basically. So we have like all these translated strings, and we also have Q-strings. And he added the ability to find like a substring in a translation and map it to a Q-string as a way of compressing it. The problem is that that means that we're using the Q-string pool stuff outside of the VM. If you have like an exception or other message that you need to decompress, when the VMs aren't running. So I had to add the ability to basically reset the Q-string stuff once the VM was done. Otherwise, the Q-string stuff has a like linked list of tables for Q-string lookup, and it adds dynamic ones to the end. And that's where you start, and then you work your way back. So after the VM, you're looking at like this one that's in the MicroPython heap. And if you do that after the VM's gone, you could just find all sorts of garbage. So you have to actually reset it to the static Q-string pools doing that. Mike Jones says, accessing memory when something shouldn't because it's not there anymore. The challenges of managing dynamic memory. Yes, and maybe this is a better segue that I should talk about the future. The future. Let me just go through this. So this is turning it back on, Q-string reset. I'll get back to that in a moment because yes, it's difficult. I no FPS limit. Oh, so in this, it turns out that frame buffer display did not have like the more modern refresh function. I was like really frustrated with it, and I was like, didn't we fix this? And yes, we did, but we did on display, not frame buffer display. So with CircuitPython 9, refresh on frame buffer display will work like the other displays refresh, which is basically it refreshes when you call it, unless you give it these target frame rates, which was like something I added originally, and then we're like, this is like really hard to use. So now it should work as you expect, and it will work like display. So I changed that, and that was really good because it was like driving me a little bonkers. Like I had this animation, actually I can turn it on. And maybe you can, I don't know how well this is working. It's still like really slow. And it looks like this is the hover cam here, but if I switch to it, it doesn't work. Like it doesn't come up. If I unplug it and plug it back in, I can show you this animation. Turn it off and back on again. I did find my LED plastic that makes it look really good. Oh, and it's dusty. Now my jeans are dusty. But I made an animation that did dots in both directions on the display as a way to like debug the mapping. Hey, there we go. Let's lock. I think it should just come up. Hacktoberfest shirt. So I have too many things on my desk, as always. I have more space and I still have too many things. Oh dear. That's my USB hub that just fell down. This is the live TV equivalent of things. Okay, so we're still pointing too far down. Let's take a look at this matrix. We are upside down. All right, let's plug this in and see what it's doing. I think it might be mismapped. And it's just not working. Yeah, anyway. Let's talk about the memory stuff. It's more interesting. Yeah, the refresh is getting updated, which is good. That's most of what the changes in here are, along with this this queue-string reset stuff and turning it back on, and then that combines with the other fixes for that. So yes, let's get back to... Beata says, I recall some of the memory talk way back when Macs weren't even fully 32-bit. I think they had similar sorts of problems. Yeah, so I spent a lot of time last week thinking, oh, like, what is the right solution to this, right? Like, how do, you know, I talked about this fix where, like, I'm giving memory to ProtoMatter, but then I'm moving it, and, like, I like, was Googling on my phone during a lunch being like, oh, like, how do I, like, what's the right way to do this? How do embedded projects manage kind of compacting memory? So, like, it's a class of garbage collector where at a point where it does a collection, it will compact things as well. But if you move pointers, you have to have this layer of indirection, or you have to know all of the places to update. And it's just a huge pain. So I was like looking, trying to figure out how people do this. And then I realized we probably should just not do that. We probably shouldn't do that. And we've been talking a little bit about this feature that's in MicroPython 1.21, which just came out yesterday. And let me find it. Or actually, let's just pull up the release notes. I will show my desktop. So released yesterday, MicroPython 121, which is awesome. Congrats to them. But the thing that they added in 121 that's very interesting to me is this MicroPy GC split heap auto. So in 120, they add the ability of doing split heaps, which is the current way that it works in CircuitPython and used to work, or it works on some ports in MicroPython this way. But basically, right before you start the VM, you say, what is the biggest amount of memory that I can get as one big chunk? And that's going to be my MicroPython VM heap. The problem with that is that if you are doing other allocations, you may have like a small region, or there's some microcontrollers where you have like multiple memory regions. So like an ESP has both the internal RAM and the external PS RAM. And in CircuitPython, we just designate external PS RAM basically to CircuitPython, and that's our big heap chunk. But we've started to introduce this like reserved heap stuff. So like in CircuitPython, you could say like only take or like leave set aside some other chunk of PS RAM to use in the IDF's memory allocations. And that's great for cameras or other like drivers that need it. SSL stuff can go there too. Which is, yeah, so especially on the ESP, you have this problem or this challenge where not only do you have a MicroPython VM, but you also have that's doing memory management, but you also have this outer real-time operating system that has managed memory or dynamic memory in and of itself. So in MicroPython 121, they've taken this split heap idea, this split heap support, and basically added the ability to add additional memory to the MicroPython heap as you need it. So instead of getting one big chunk or two big chunks that you do up front, what they do in 121 on ESP is they start with a 64K chunk, and then the MicroPython heap has been reworked on this port to support the large variety of memory configurations. It now starts at 64 kilobytes and automatically grows as needed. And the way that it grows is that it asks the outer heap, the ESP IDF's heap, hey, give me another chunk that I can allocate MicroPython stuff into. And a consequence is that you only need to manage as much memory as you're using. So this means that boards with SPI-RAM have much faster GC collection times if only using a small amount of RAM. But if you want to use a lot from Python, you can. But also correspondingly, now the IDF can use memory as well. So this is really cool because it allows for better sharing of memory in Python and outside of Python. And if we go back to what the challenge with ProtoMatter was, is that particularly for displays like RGB Matrix displays, CircuitPython does these really tricky tricks so that the display stuff stays alive even after the VM is gone. That's why we have this like move memory sorts of stuff, which is, as I said, really hard to maintain. So I got really excited and basically said, like, I've decided, and I kind of like worked on it some, is that in CircuitPython 9, we'll do what MicroPython is doing on the ESP32, but we'll do it on all of our ports. Because all of our ports may need this ability to allocate memory that lives longer than the MicroPython VM. So by having a split heap that gets chunks allocated as you need, you probably have space outside of that for any allocations you need to do that should live longer than the MicroPython heap. That's the theory. I've like half implemented it. I ripped out all of the supervisor memory stuff, but because we're not up to date with MicroPython 121 yet, I can't really like piece it all together for 9 yet. Mike says, I just got into MCUs, no expert, and was reading it to avoid dynamic memory in MCU programming because of the headaches involved. But I guess that's unavoidable if you want to use things like MicroPython. Yeah, so I think there's actually a lot of, well, there's potentially some really good room for optimization, like thinking about tinyusb. A lot of our static RAM allocation is buffers for USB. But imagine that you have user code that turns off a portion. So like there's a MIDI buffer or a mass storage buffer. Right now, tinyusb is all statically allocated. So if you want to maybe use mass storage, there's going to be a 512 byte buffer that is just constantly, always in your RAM, even if you've turned it off and you're not using it. So by moving to the system where we have dynamic memory that's properly managed outside of the Python VM, we can be much more, it's much simpler for us to just like put stuff in there. So yeah, CircuitPython in general is much more dynamic than a lot of C programs because we don't know what user code's going to do, so we have to kind of like prepare for all cases. We have to be a lot more dynamic than even a lot of vendor SDKs expect us to be. So I started that branch, and we can find which branch it is. This branches view is really helpful because it has like recently activated ones. So here's my switch to split heap. It doesn't build yet. on everything, but I could go back and fix it. It's a lot of, this commit is wrong. This diff is going to be wrong, but I just straight up deleted the supervisor memory allocator stuff, and then had to fix everything that used it. And I'm using this memory allocator called tlsf, which the espressif folks actually use and maintain a fork of. They use it in the IDF5. So on ports besides espressif, we just use tlsf ourselves. We use tlsf ourselves directly instead of on espressif. We'll just use it via the IDF. So yeah, now when we do things like allocate PyStack, it just gets done with this new port malloc call instead of doing the like allocate memory, which was the old API to the supervisor stuff. And you can call port malloc even when the VM's running, and you'll get memory that can stay where it is. You will fragment your big region, but with split heaps, MicroPython will still be able to like bridge that region. You only risk that you can't do like super large contiguous Python allocations at that point, which is a trade-off, and it'll be very interesting to see like what projects have more trouble and that sort of thing. But yeah, so this branch that I've got going is like halfway there. We really need like MicroPython 121 with the split heap growing to be able to actually fully switch to it. But I've ripped it all out. Right now, in this branch, I'm just allocating a very small heap. So I was able to like test that it does work. And yeah, like I deleted lots of stuff. Everything is going to have a fixed stack. We used to have this ability to like change the stack size on the fly, but that was only on some ports. And I don't think anybody actually uses it. So I just ripped it out. I don't want to have to maintain it anymore because it's tricky. Reserve PSRAM is gone because now you don't need to reserve it. You just hope you can get it when you need it. And we're switching over. We used to do on espressif this SpyRAM use memmap. We won't need that anymore because we'll just allocate as we need from the IDF. So on the IDF, on the espressif port, you see we just call heap caps malloc instead. Which is great. So we have better integration with RTOSes that run underneath us, and yeah, they don't lose a bunch of memory either. It's kind of a like whoever uses it can use it until it's gone. And then on all the other ports, they have to give like top and bottom for the heap, and then the TLSF will be used directly for those ports. But yeah, there's all these warts that go away. So like, there's this structure that tells you like what code file to run the next time the VM runs, and that had to use all this fancy allocate memory stuff. Previous traceback string had to happen that way. Custom USB stuff was really tricky, where like there was this like save to this temporary buffer call and all that. So hopefully it's going to clean up the memory management a lot and still allow us to do things. So like now all of these things don't have to store this like wrapper object. They can just store the pointer because the pointer stays valid. So it simplifies things a lot. And I don't think the things that stored these allocations, like I don't think they usually check to make sure it hasn't been moved. Yeah, you can see I deleted the the header file completely. So yeah, that's the future of memory management. It should be easier for us to maintain. This doesn't redo all of the display stuff. I'm still thinking about that because we have a limit right now on like how many displays you can have active at once, and so people have to recompile CircuitPython to do it. But there's really no reason that we actually have to have that limitation when we can more freely dynamically allocate things that live longer. We don't need to set aside this fixed static memory for all the displays at that point. So a follow-up to this switch would be like changing how displays work, so you can just make as many displays as you want, and then the terminal will only show up on the first one. And potentially, I haven't decided this, but like potentially the first one is the only one that would stay alive past the VM. So yeah, if you have thoughts about that, let me know. Yeah, 384 lines of this like complicated moving stuff I just deleted, which is cool. And these are the default versions of Port Malloc. They just use the tlsf stuff. Yeah. So that's coming, but it depends on us getting all the way up to date with CircuitPython or MicroPython 121, which is just released. So after doing all this, I was like, oh, I gotta help Dan. Dan is working off and on the MicroPython 120 merge. So it includes split heap support, but it doesn't have the code that auto grows. So I think we'll go even a little further and get to 121. And I also want to like upstream some changes that I've found as I've been fixing stuff. So Dan's been working on getting things building, and I've been working on getting tests fixed in the merged version of CircuitPython for 120. So I've got the CI going and nothing builds. So that's where I'm at, is I just got the boards actually building because I had to get mpy-cross building. David says, recall a while ago you were working on bare metal CircuitPython on the Raspberry Pi. Now that the Pi 5 is out with dual displays, do you see this on the timeline? Does Adafruit have other multiple display products? So I think the Pi 4 can do 2 displays as well, so I don't think that's new. David asks, will this new method reduce the compiled size? I haven't measured it. Dan and I briefly looked at how much code size the tlsf stuff takes, and it's about 3K, I think. Is this, yeah, if we could just look at my CI run. And see, okay, so tests failed. Okay, so yeah, I have to fix the Unix port on this prototype branch before I know. I'm hoping it'll be about the same, but time will tell. And we're currently going through a lot of compile size churn anyway with the MicroPython updates. And then another to-do for CircuitPython 9 is updating the compiler itself as well. So there's going to be like at least some like degree of noise in terms of compiled size. Adafruit has one multiple display product, and it's the mask with the 2 displays. And I think for that board we set it to 2. I was thinking about if you could, this is a bigger rework of display I/O, but if you had like a terminal and it could go across the 2 displays, would be pretty neat. But right now, all of the groups and all of the tile grids assume they're only in 1 display. So there's like transformation stuff from the root display that gets propagated down. It's not simple code. I do hope, going back to you, David Buchanan, I do hope that the new memory allocation stuff will actually allow us to to have fewer static buffers, which will give us more heap space. And so your heap usage should be a little bit more flexible in 9 than it was in 8, which is actually hopefully helpful on the CMD21. But that a lot of the buffers, it's like 5K of RAM that's statically allocated, and that's mostly USB buffers. So it's potentially a pretty big rewrite of tinyusb. Or at least like making it configurable to do dynamic memory rather than static memory. But could be helpful for us, especially because those buffers can be like, you know, half a K to a couple K. Yeah, I probably won't spend time on getting the Pi 5 running bare metal CircuitPython, but hopefully somebody else will. My core interest still is in the Pi 400 because it's self-contained with a keyboard. That is still my ideal use case for bare metal CircuitPython. But now that we have USB host in CircuitPython and this dot clock display stuff, so not the RGB Matrix stuff, but these round displays, which I'm not sure I showed. But on espressif, we have these like round displays, and they're this like 40 pin, and there's no frame buffer on the display. So you have a big frame buffer in the PS RAM that gets spit out every frame. Like between that and the USB host, we might actually start to be able to like make self-contained CircuitPython computers, kind of like I imagined for the Pi 400, but not using the Pi 400. Any other questions? Let's see. I thought that these builds would succeed, but all of them failed, it looks like. Everything is red, so we'll take a look at that. I thought Dan was getting them running, but he's doing it locally, not on the CI. And the CI was like surprisingly tricky. Build board, build release files, get settings from make file, is invoking make with print C flags. Okay. So this is something we should be able to reproduce locally. So this is trying to build the shared bindings matrix. So this is like if you build the board directly, you're not going to find it, but if you try to build it from within, like we have a helper script. Let's see what this is doing. No rule to make target print C flags. So there's probably something that was deleted. So most of what these fixes have been of like, okay, what's missing, or why did it used to work and now doesn't? Why doesn't it work now? Oh, so this is just main. So what if we just do print dash? Yeah, so here's under pi make rules. And we can see that it's at the bottom, and if we blame it, it's probably something. So this had to do with the commit, and then it disappears for that. Here's print config. If we go and look at this, Oh, so yeah, like it looks like Dan factored it out. But then this pymake is probably, it probably got deleted from there because that's the one that we share with CircuitPython or with MicroPython. So it's, he puts it in pymake rules, but I think we could probably put it in. All right. I wonder if we could put it in the CircuitPython make file just so that it doesn't get accidentally dropped just like it did. So maybe we can put it in make environment. Let's just put it here. That's not what I want. I want the whole thing. Definitions. Those are make rules. Oh yeah, this is the right place to put it. So let's see if this works now. Hey-oh, we got output. Okay, so now we stage it and we see if it works. Does copy paste handle makefile tabs for you? I don't know. Looks like I did get a tab there, so that looks right. So we'll stage that, and now we'll commit it. Add back, makefile, print variable. And we'll push it. Yeah, so I'm like, I was very excited about this allocation stuff because it'll make it much easier. Like we won't be bounded about the number of allocations we can do now. Like right now we have this static array of these supervisor allocations that limits how many you can do, and it's just like a whole bunch of complicated code for moving it. And one thing that Tak was talking about, so he added support to tinyusb for a USB host chip that's connected over SPI. And this is something Limor just previewed for a new Featherwing that is a like USB host Featherwing that has this chip on it. And he was talking about needing or wanting like a malloc free for tinyusb for that support. So switching to tlsf will give us that ability, which would be great. Okay, so now that we push that new thing, we watch the CI run. It's kind of like, I reproduced it somewhat locally. And I guess I could run that release build script. But which host chip? The Max 3421? I think, if I remember right. tinyusb. Yeah, Max 3421. Yep. So he's been working on it and testing it from Arduino, and then later we figure out how to do it in CircuitPython. And this is the perfect example of like, we really want dynamic memory because we want support for it, but we have no idea if we're actually going to use it. And with USB host, we also, just like displays, that's something where we want it to run outside of the Python VM as well. So yeah, the thing I've got to figure out is like both displays and this USB host stuff can use like I2C and SPI buses, and those typically still get allocated. Like the board ones are special; they get allocated statically, but but most of them are dynamically allocated in the MicroPython heap. But then if they might be used by a display, or they might be used by this USB host stuff, and so it's tricky to know what the right way of, like, do you just always allocate these things outside the VM heap, or do you still do some sort of like cloning out of the VM heap when you need it, or something like that? I haven't figured that out yet. All right, so it's going to kick off all the board jobs now because we didn't break mpy-cross, which is great. The Mac one is still broken, so maybe while we're waiting for the other ones, we should take a look at this. And you can see here that it's like triggering the 400 board builds. So this one's a little bit interesting because I should probably actually use my laptop. Like I could actually build this on my laptop to get it fixed, because my laptop is a Mac. And these errors are clearly like compiler related. Although yeah, so that could be another like iterate via the CI, which is annoying. But let's take a look here. I wonder if the docs build will work. I'm not sure it did last time. I was pretty excited just to get to this point though, of like being able to narrow down like which boards are building successfully or not. I know Dan's working on that, but getting it done in the CI is another helpful thing. Do those plans sound good to folks? What feedback do you have for me? I do feel like we're making good progress into the like CircuitPython 9 land. Like the IDF is up to date. 119's merged in, 120's close, 121 is now out. So we can go a little crazy and go straight to that. And we'll be up to date. And I do want to have a discussion with the MicroPython folks about like getting all these sort of random things upstreamed. Yeah, Beata says that is the same chip that is on the Arduino host shields I have. Yep. Hoping to review the Max 3421 with tinyusb support. Thanks for mentioning it. No problem. It doesn't have. We intend on supporting it in CircuitPython, but we don't yet. And yeah, I have like the SparkFun host shield to test with. I haven't gotten that far, but. What would you think of a logo to MPY compiler? I have no background with logo, so it's kind of hard for me to say. I would say if you're gonna do that, just go to Python. Don't go to MPY. Just go from logo to the equivalent Python code. You can always run mpy-cross on the Python code. If you wanted to get really fancy, you could write a Python script to load logo dynamically and run it. That would be kind of wild. Uh-oh. Our boards are still not building. Let's take a look. So Presence has a bunch of build failures. I know RB2040 should be working. These are probably things that Dan's worked on. Let's see if if any of them do succeed before we dive into them. I do actually have to like I'll have to coordinate with Dan too. I don't know if he's working on anything specifically. Like if I could pick up a different port or something from what he's doing. So NRF and Broadcom are going. I think the Trinket M0 builds, so that should work. It builds locally, I think. Unexpected Maker, what board of yours doesn't work? I've got like half hour. Maybe I could do that concurrently with waiting for the CI to run. Although I don't know if espressif board's working in 120 either. Okay, so that compiled. Let's do an espressif. Let's see if these work. Let's see. What do I want to test on? Probably one of the espressif. The C6? Sure, why not? I don't know whether it has it or not, actually. No, it doesn't. All of them, when referencing boards.xxx pins. Okay. I think I've got S3s on my desk here. Whoa! Don't pull out my mic. That's not what I want though. I really like these new dev boards from the espressif dev boards with dual USB are really nice. They're really helpful for debugging. Okay, so this is a espressif S3 dev kit C. Not the N32. And 8. Unexpected Makers in chatting in Discord, but not YouTube. Been reported on Tiny S3, Feather S3, Safari, but I assume it's the same with all at least S3 boards. Comes back with invalid pin. Okay, so we clean. Let's build. Oh man. Probably not. Ah. Oh, what did I do? That's not what I want. Oh, this is CircuitPython 8, so don't do that. I'm going to start over because I think I've got to update the IDF to whatever this merge is using. Let's just see where we're at here. Did we get any boards that built okay? I'm not sure this has the 5.1 stuff in it. NRF's going. All right, I think let's just switch. Ah, yes. Paul. Invalid pin. Analogin board.battery. Version 9.0 alpha 1 AAAD. You know, I think I might have fixed this actually. Because they changed the indexing of the ADC units. So this is specifically for analog in. I think I fixed it. Oh, it's not gonna find it if it's that long. AA0. There it is. It's here, dot clock overscan. But does that have my changes? It looks like it does. Fix ESP32 with 5.1. Okay, so yeah, let's just try it. I'll give it a shot. What am I thinking? Oh, I want to get out of the merge. Fetch Adafruit. Let's do main test pin. Yeah. Do not care. Do not care. Oh, come on. Need to update everything, make fetch all submodules. U-bus pin is not an ADC pin, no, it's just a digital read. Yeah, we'll try it. I'll give it a shot. I'm going to do it on the espressif board, but I'm assuming it would have the same problem. I'll do it on the S3. But there was a problem with, there was an issue with analog. Like, it used to be the unit was 1 or 2, and now in 5, it's 0 or 1, I think. I think I did fix that. So I've had this problem, and I think I found an issue with Git. I tried to file an issue. They don't have an issue tracker. They have a mailing list where no one replies to you when you send an email. It's been very annoying. But test pin, if you delete the remote, it should work. The problem is that it's trying to fetch from the wrong remote. Commit the changes or stash your changes. ESP camera. Oh, it's so annoying. I feel like the submodule stuff has just stopped working as well. It shouldn't be. I don't have any changes. board VBus. Yeah, I don't know. Yeah, if you're trying to do an analog read on the wrong pin, that would do it too. But there was an issue with, like, in CircuitPython 8, like pre-IDF5, if a pin didn't have an ADC, it set the value to 0. But then in IDF5, they made it 0 and 1, so I had to change the no ADC pin to not be 0. But then I think I fixed it. Okay. I don't know, all this garbage. That should be close enough, though. Ports, espressif, ESP, F, export. Huh. All right, I could install again, I guess. I don't know why. Issue from Mu editor REPL. Import board followed by dir board. Let's take a look at our. Heyo! We have NRF boards that are compiling okay. Yeah, so I think I'm taking Monday off, but when I come back on Tuesday, it's fix the builds, fix the boards that don't work week for 120. It is interesting, there's some here that still don't build. It's probably just a size issue. Yeah, like most of them work, but like German failed by 4 bytes. 4 bytes too big. That's real close. 4 bytes. I hate it when that happens. That's like if you just do a tag and your version string's shorter, it'll fit. Yeah, that's what's nice about running the CI. This one's significantly larger. mpy-cross not found. Interesting. It should have mpy-cross. Like there's this setup mpy. Ah. Oh, it put it in the wrong place. Ooh, I wonder how many things. That's right. Setup. Okay, that makes sense to me. I was doing a lot of stuff around this. In GitHub, Actions, mpy-cross, download. Make it executable. Why is it? Download artifacts. Upload artifacts. Is that right? I wonder if this needs to be... It looks like it successfully... Artifact mpy-cross was downloaded to CircuitPython mpy-cross. And then we do successfully manage to change it to execute. But then there's a syntax warning. And then the build fails. Make C mpy-cross. Oh! We're doing another mpy-cross build, which we don't need to do. Now I'm getting distracted again. This is the challenge of doing two things at once. Like, now I want to update this script to not make mpy-cross at all, because there's already this thing that's getting a cached version. Like, it built and linked it, but now it put it in this other place. It built it under there. Which is weird, but like, it would be nice to save time. I wonder if that's only for frozen stuff that we build mpy-cross again. I bet that's what it is. All right, let's stop getting distracted. I don't want to fix the script. I'm in the wrong branch. I'm in the branch to do all the ESP stuff. Okay, so we have a build. And let me get set up. Just about out of time for today, but that's the way it goes. And that's the way it goes when you compile OBS yourself. No. I was holding the wrong. That is the right one. I wasn't in the right boot mode. And I like to have to-dev serial by ID USB Silicon Labs, which is the uart to serial converter. And then after it finishes, I hit reset and I load CircuitPython and I do dev serial by ID USB. It didn't start. That's not good. Oh, it's out there. There it is. There's the S3 CircuitPython stuff. And it's not a debug build, so it's not showing up on the left. Now we have the REPL though. So we can do import board, dir board, board.io0, import analog IO, A equals analog IO dot analog in, board dot, I actually don't know if 0 is valid. So IO0 invalid pin, but does that actually, is that correct or not? We can go to ports, espressif. It may not be on IO0. Ports, espressif, peripherals, S3 pins. Yeah, so pin 0 has no ADC. And so let's try pin 1. So analog in pin 1 does not work as well, which it should. Assuming we want to use ADC unit 1. So let's try 11 now. Board.battery. Yeah, so 11 works. I think, let me look at this. There was something between the two units. Let's look here. Analog IO, analog in. ADC index equals 0. So that's the problem, is that that's not right. It should be ADC index is whatever the no, like yeah, okay. You found a bug. Good. This is an easy fix. Peripherals, pin. Oh, here it is. It's this no ADC. Didn't I fix that? Where did I fix this? Maybe I missed it? I totally fixed this once already. Sock num ADC units. Did I not fix that? Where did I fix that? Well, I don't remember. Maybe I missed it. I found the issue, I fixed it, and then failed to get it merged in. Because I don't think I have any open PRs. S3 pin mapping for RGB, but that's not going to have. There. Huh. Well, I missed it. Ports, espressif, peripherals, and it's update ADC and I2S APIs. Yeah, it's fixed here. That's what I would expect it to be. What brand? What am I on? This is main. I could have sworn I switched to main. Where am I in history? Enable RGB Matrix on IDF 5.1. C9D. October 6th, today. And yet, ports espressif peripherals pins.h is wrong? I missing? Yeah, see this is... Am I on... Enable RGB Matrix. I'm very confused. How would Git help you find this fix? Well, like I fixed it already. Why is this file not right? Am I in the wrong world? Okay, so it's correct. This must be like a cached. Oh, you know what? This is in my CircuitPython 8 directory. That's why it's not there. Okay, let's close that because it's confusing me. This is where we want to look. So here we look, pins H, no ADC, but I think the problem is that I did not update analog IO, analog in to say no ADC here. I think that's my problem, is that I had the magic 0. Okay, so let's give it a try. Let's reset. Woo! Going a little wild there. Just about ready to wrap up, but if you have any other questions, please ask them now, and we'll happy to do it. I should be able to get a PR out for this in the next 5 minutes. It's a super simple fix. We just gotta test it because I knew what the issue was. Okay, so we want to test analog in on board IO1. Oh, come on. Wi-Fi is doing stuff. Import board, import analog IO. A equals analog IO, analog in board dot IO1. Hey, it works now. A dot value. It's not connected to anything, so it won't right. But it'll allow you to now. Okay, so that is the problem. Let's pull up our thing here and hit stage. I hit the stage button. You can't see it, but. Fix ADC tests. ESP5. IDF5. Get status. Git commit. Okay, so there's no issue for this. So I'll just fix pin ADC unit check. IDF5 made. 0 valid. Okay. Yeah, lots of stuff, like, that's totally the sort of thing I expect to find. So let me know, file an issue if you find more stuff like that. Jeff is gone for a few weeks, so I'm not going to have him know it. Sweet. Awesome. Well, that is a good way to wrap up. The CI is still churning through. Oh, look, most of the STM boards built. CI is still churning on giving us an update on where we're at. I think my guess is a lot of these have frozen modules. You saw me test it. It's not going to break anything else. We'll keep an eye on here. Yeah, so we got a ways to go on the 120 merge. But we'll get there. All the Raspberry Pi boards failed, even though I thought Dan fixed those. But yeah, so that's what's next up for me is... Well, this is like submodule problems. Great. Great. All right, so let me go back here. Thank you, everybody, for joining me on this deep dive. Next week, I am off, but Foamy Guy said that they can do it. So stop by this time next week for Foamy Guy's deep dive into the world of Python on CircuitPython. My name is Scott. I go by TanNewt online. If you want to support me, you can do that by supporting Adafruit. They do a great job supporting me. And do that by going to adafruit.com. If you want to join the chat that lasts all day, all week, join our Discord server with the URL adafru.it/discord. I tend to hang out in the CircuitPython-dev channel. I do go over the help with CircuitPython channel from time to time as well. Thanks again to DCD, who usually takes timecodes. I really appreciate that. I have to make sure I remember to... I'm not sure I updated last week's or the week before, so I'll take a look at that as well. And yeah, please try out main. Obviously, it's a little rough, but we're going to get there. We're going to get the MicroPython merges in. We have the IDF in, and then we'll polish it up and do that. So yeah, no cats, so no cat cam. This does work, which is cool, but it's crashing for some reason. The matrix is crashing for some reason, so oh well. Thank you all for hanging out there. Thanks for hanging with me as I figured out my OBS problems. Hopefully in a couple weeks I'll remember to turn it on or try to run OBS before I need to get on immediately. And we'll have a little bit more time to fix it myself. All right, with that, everybody have a great weekend. I'm going to be around, like, I'm going to take some days off next week, but I'll be around through the core of the week, the middle of the week. So I'll chat with you then. And have a great weekend, and I'll see you probably in 2 weeks. I haven't looked at my calendar. I should be able to do it in 2 weeks, but I got to look first. And I'll let you know. If you want to get notified about changes, you can join the Deep Divers role on Discord. Just if you're on Discord, just ping me, say like, hey, I want the role. And then we use it very sparingly, but just as a like heads up, I'm not streaming today, that sort of stuff. So there's a role there on Discord for you if you want to get notified by me or Foamy Guy about it. Anyway, thanks all, and have a great weekend.